Hello. Hello, everybody. Today we're going to be talking about physically simulated clothing by CCP, also known as EVE Online, using NVIDIA Apex. And let me introduce everybody before we start. Over here we have Vigfús Ómarsson, lead technical artist from CCP, as well as Snorri Stroesen, the senior software engineer at CCP, and myself, Monia Meher. I'm the Apex manager, product manager. So we're first going to provide you a quick overview of what Apex actually is, what it stands for. Then afterwards, Vigfús is going to give a presentation in regards to how they implemented clothing, and he's going to show the tool flow as well as live demos. And then afterwards, we're going to provide a quick overview over additional Apex modules which we have, for example, destruction, particles, vegetation, and turbulence. So what is actually Apex? Apex is a scalable dynamics framework. So what does that actually mean? It's basically scalable because you can author art once, and then you can automatically scale it down to the different hardware platforms, consoles or PCs. And that really allows you to leverage the best out of the different compute platforms. It's dynamics because we basically deal with everything which moves and interact. And it's a structured environment. Basically, everything sits on top of our Apex framework. There we have the different modules like clothing and destruction. And if you implement that Apex framework, you're able to immediately basically use different modules. And there's a global level of detail system even going on. So, I mean, it's a real framework. Apex consists of two major components. We have the authoring component and the runtime component. In the authoring, we really wanted to make sure that the artist is sitting in the driver's seat. So it's a high-level authoring, and artists can basically generate any content without going to a physics engineer and asking them, okay, how do I do that? How can I implement this? When they don't need any support engineers as well for that. And then we have the runtime. That's a modular SDK, which sits on top of our physics SDK. So over here, that's basically the diagram. You see how the Apex core itself is sitting on top of the physics SDK. In addition, we actually have an interface to the render interface of the game itself, and that allows us to quickly get, thousands of particles, for example, visualized. On top of the Apex core, you can plug in the different modules like destruction, clothing, and vegetation, and then you can scale them based on hardware platform, and the scalability and level of detail is actually done across all modules. We wanted to make sure that Apex is really artist focused, and you're going to see that Vigfús is going to show how we integrated clothing into, for example, the Max and Maya plugins. With that said, I'm going to give over to Vigfús.
Thanks. So hi, I'm Vigfús, lead technical artist of CCP. And what I'm going to do is I'm going to show you, it's basically a case study of what CCP did with Apex, how we integrated it into our tool set, and some live demos of actual assets being created in Maya. So the first thing to think about, of course, if you're trying to decide whether to go with cloth simulation or not, is, why use it? Why use cloth simulation? And the obvious answer is of course, it's a relatively easy way to get, secondary motion and simulation effects to make pretty much any sort of game a bit more plausible. Not necessarily realistic, but, it is a simulation layer that just goes on top of what you already have, and you yourself decide how elaborate you choose to make it. Also, the same toolset does soft body simulation, and soft bodies are something that can be used in pretty much anything, including really cartoony games. There are a lot of things to be aware of when it comes to simulation. We've all seen how ragdolls have evolved over the years. It's started out a bit rough, but then people learn how to use them properly, and now they're getting really good. And like any other simulation, cloth simulation is not just something you drag and drop into your game. There are things you need to be aware of. In general, letting the simulation Go is not a good idea. You have to basically take control over it. You have to choreograph it. There are a number of tools to do this. But in general, it's not very hard to create cloth that looks pretty good. You can make a fabulous Cinderella dress pretty quickly, pretty easily, and it'll look absolutely fabulous standing on a ballroom, twirling around and dancing. But if you then put it in a wrestling game and someone comes and gives Cinderella a pile driver, who knows what's going to happen? You have to be aware, basically, what's going to happen to your cloth and how are you going to keep it looking nice. Of course, you always have the option to simply fade out simulation while something really wild happens. But anyway, it's in general, the more the more power and majesty you want to get out of the cloth, the more responsibility you have to build into it. And of course, iterating on it is the key to all of this. At CCP, we integrated basically Apex along with everything else into our standard pipeline. We try to, most of the time, just keep it to a single button export. So no matter what you're building, you don't need to think about it too much. You just press export and you're done. Getting Apex to fit into that was really easy. You basically just call a command and say, my mesh that happens to be the cloth mesh in the scene simply gets exported into, the Apex format, the ACA file, and then you're pretty much ready to go. Now I'm going to do a live Maya demo, just showing off some of the stuff that Apex can do. So Apex is integrated directly into Maya, so it fits into the construction history modeling framework. First, I'm just going to build a real quick Apex mesh and just show you how that works. Creating a simple plane, simple joint. Apex always works on jointed models. Just going to bind it to that. And then to turn this into a cloth mesh, all I have to do is simply just go into the physics menu. Apex is part of the physics tool set. So if you used physics before, a lot of it will be familiar. Create clothing, and we're done. This is now a clothing asset. Of course, it's completely unrestricted, so we won't see a lot of interesting stuff happening just yet. The cloth simply falls to the ground. The most important aspect of controlling the cloth is something called the max distance. Max distance is basically how far is the cloth allowed to travel away from the position that the skeleton put it in. That means that if you want to be really careful and not worry about your clothes getting all tangled, simply control your max distance. Don't allow your cloth to move more than, say, a foot in each direction, or only allow it to move outwards instead of inwards. This is all the safety measures that allow you to do this relatively cheaply because you don't have to worry about things breaking as easily. So what I'm going to do is I just painted everything to have a freedom value of 100. I'm going to take one of the rims and turn it to 0. And as you'd expect, this is what happens. As you can see, it runs in Maya at a really good speed. And also, pretty much all the features of Apex are available here. So you want to preview it with the wind. Go ahead, add some wind to it. And of course, if you've used physics before, a lot of the old familiar tools integrated with it already. So just going to create a little box, place it under here, make it a little bigger. The normal physics tools, I'm going to create a kinematic rigid body, and it'll collide. Just going to adjust the thickness a little so it And there you go. So, and this is just a normal, construction history in Maya. So actually what you could do if you wanted is, this mesh is simulated. I'm going to add some more stuff to the construction history, for example, a smooth modifier. Now, the smoothing is happening after the simulation. Of course, it does slow it down a little bit. But as you can see, it still works. And even if you have no intention of using cloth simulation in your game engine, right there you've got a way to generate meshes. You can make normal maps out of this. And this stuff is really fun to play around with. It is really fast. It does simulate in real time, and you can do all kinds of pretty nifty stuff with it. All right, I'm going to switch gears a little bit. I'm going to actually take a clothing asset from the CCP character system and set it up for cloth from scratch. Of course, this is done to maximize the potential for chaos and mayhem. So what I've got here is a trench coat. The trench coat right now, the only thing it has is a skin cluster that is bones to allow it to move around. I'm going to be putting it onto this girl here. So basically, she's not wearing much of anything because I haven't exported the trench coat yet. So the first thing I'm going to do is, of course, I'm going to take the trench coat and turn it into an Apex clothing mesh. And like before I start working, all that happens is that the default max distance is the amount that the jacket, folds to the ground by. This is as far as it's allowed to go. So I'm going to start by just painting max distance. To begin with, I'm going to take away all its movement freedom. So now it actually, if I were to export it right now, you would only see the motion that comes from the skeleton itself. In this case, I'm going to make the jacket have a really large range of motion down here. If I were being a bit more careful, I would, restrict it a bit, just to get less risk of anything getting tangled in the wind and so on. So just bear with me for 1 second. And I think that's it. Now the jacket is actually simulated, and I can test it out, in the viewport. Now this is pretty nice. When doing your first set of iterations, being able to just see it in the viewport is pretty useful. You will notice that the jacket is constructed in such a way that it is actually double-sided. So there are outside and inside polygons. And I'm going to show you a little bit how you handle meshes like that, because obviously you don't want the simulation to be running on both the inside and the outside. I'm just going to smooth this out a little bit using the paint tool. But as you can see, the paint tool has actually been customized to some extent. You see these ranges here. When you're fine-tuning cloth, especially the border between where it starts simulating and where it doesn't, having these ranges is a really handy way to basically get precise control over exactly how much it's moving. The end of a scarf may be able to move several meters, but where it tapers in, you need sub-inch control. So anyway, I'm going to export this. Switch back to the girl, and there it is. As you can see, this is very rough. All I really did was give a few birds the freedom to move around. As you can see, it's not colliding against her legs, and on the border, between simulation and non-simulation, it's pretty sharp and a bit rough. So we're going to refine it a bit. The first thing is I'm going to make sure that the inside isn't taking up unnecessary resources on simulation. So I'm going to paint a channel called used for physics. 0 to 1 value, anything that is black in this channel simply doesn't simulate by itself. It simulates along with the verts that it's closest to. And it's pretty much made for this. I'm basically just painting these things out so they don't interfere with the outer simulation, but yet they simulate along with them. Of course, you could also solve this by just simply not having an inside. So anyway, as you can see, of course, the painting is pretty rough and imperfect. But if I wanted to, make sure that everything was, working okay, there are a lot of visualizations inside of Maya, like for example here, physical mesh. This is the mesh that's actually getting simulated. The rest of it isn't. And also I could also visualize all kinds of things like, my max distances. How far is 100 actually? And we're going to show you that in Engine later. So anyway, I'm going to do a quick update here. And this smoothed out the simulation a little bit and made it cheaper in the runtime. Now, of course, the most important thing is left, and that is collision. Doesn't work quite well enough to have it like this. Even if the simulation is already starting to, look pretty decent, this won't fly. So creating collisions is actually a really simple process. So basically, I have this mesh that represents, the best standard set of pants, in a game that is an MMO where the character could be wearing any number of pants. As you can see, the legs, have a fairly special shape. It's basically something we arrived at by trial and error. It's a little wider than the nude mesh. And we have these platform shoes to make it easier to use skirts that slide along the ground and stuff like that. Just see. And the process of creating the collision is really simple. All I do is I just select the bones that I want to participate in this. In this case, the legs of the skeleton. I simply bind it. Then I just select the mesh and go into the PhysX ragdoll tools. Just create a kinematic ragdoll. And there we are. Now there is a collision. I'm going to export that real quick. And now it's getting close. As you can see, it's not quite there yet. You can see that the legs still protrude through the mesh a little bit in places, and so a little bit more tweaking is required. In this case, I can simply set the simulation thickness of the cloth to a little bit more, like say 5 or 6. And there we go. That's better. Now of course, not all assets are quite this easy to set up, and this is not necessarily, this is obviously not up to the level of something that you would publish in a game. But I still think, there's got to be something to it if you can set it up from scratch in pretty much 5 to 10 minutes. And having those tools inside Maya and being able to preview everything there, of course, makes this a fairly easy workflow. Even if you don't have a super quick way to get everything into the engine and so on, you just simply use the same meshes that the engine uses and run your simulations inside Maya. And they run at, almost full speed. All right, and that's it for the Maya demo. And of course, at CCP, there are a number of challenges that we are facing when it comes to cloth simulation. The obvious thing is, of course, we make MMOs, and if 10,000 players agree to congregate somewhere, there's not a lot we can do about it. This means that obviously we need a way to scale things down, or deactivate as needed. And of course, that is something that you can do. You can fade your simulation out, go to a straight GPU skin mesh, or use any number of options to actually generate lower fidelity cloth if you need. You have simulation meshes that can be separate from the rendered meshes, so you can actually do lower fidelity simulation on a higher res mesh. And also, for maintaining high visual fidelity. Basically, you just need to think a lot about how you set up your collision and collision meshes and things, and if you need characters to collide with each other and with the environment and things like that. Basically, this is it's not a total cakewalk. Making it look good the first time is easy. Making it look good in every conceivable situation can be quite tricky. And the assets we're going to show you in the demo later are a little bit on the unrestricted side, but we'll get there.
I'm Snorre Sturluson. I'm a senior software engineer at CCP, and I'm leading the character rendering team there, and worked on the Apex integration. And I wanted to just give you a really quick overview of what that involved. And we'll have some really cool live demos then later on. To get Apex working with our engine, there are really a few classes that I had to implement. A resource callback that manages shared objects that Apex requires. The render resource manager is managing the creation of vertex and index buffers. And the user renderer manages or performs the rendering, calling upon your engine to render those vertex and index buffers. And that's really sort of the level that it's working at, which makes it easy to integrate into any modern graphics engine. So then we create actors from clothing assets that we load from ACA files. These are the files that Vic was showing exported earlier. Create clothing actors from the asset, and then Apex renders those actors through your engine. So to this audience, what I think might be the most important is the debugging aids that we can show in the engine. Apex really provides lots of debugging info that anything that you tweak and set in Maya, there is visualization for it, so you can look at it in engine, see what's going on. So very useful for the programmers, but even more so for the authoring of cloth assets. So the programmer really needs to spend time to support all of that. And so Vic was just going to demonstrate some of these while I'm talking here. He's turned now on showing the collision volume, so you can see if that's matching with the visuals. This is representing the max distance that the cloth is allowed to simulate away from the skin positions. And then seeing the actual simulated mesh. And turn off the, so this is the actual mesh that is being simulated. The rest of it is being skinned, so there's no extra CPU time spent on simulating that. And maybe the velocities as well. So as the character is moving, her animation is providing forces that move or make the cloth vertices move. This allows you to see that. So this is all stuff you can turn on in Maya. So the first pass of authoring, very useful to see it there. This seeing it in engine, verifying that things are as you expect, can be it's very important. And then finally, there is a separate tool that NVIDIA provides, Visual Debugger for PhysX in general, and the cool thing there is that it allows recording of data, so you can look at it outside the engine. You can record while you're playing, look at it after the fact, and even zip up the file and send it off to NVIDIA engineers if there's problems that you can't figure out. And we've used that to help analyze some problems. So cloth simulation always brings up the question of performance, maximizing performance on something as heavy as cloth simulation. really is about making the GPU do as much of its work while everything else is happening. GPU can do really heavy lifting. So maximizing parallelism is in effect maximizing performance. There are maybe some compromises you have to make for that. It might mean that you have to delay skinning to match up the simulation and allow basically the simulation to lag behind. In most cases, that's just a good thing. It gives you a higher frame rate. But if you're a very action-oriented game, it may mean issues with syncing audio and other effects. As the animation is now running 2, 3, maybe up to 5 frames ahead of what's ending up on screen. Apex doesn't force any of this upon us, but if you want to really maximize the performance, get to the higher frame rate, you may have to introduce more lag. So just in a quick summary before we then move on to live demos. So benefits of Apex is, as you've seen, fast and easily iterated authoring, and very artist-friendly. I'm not an artist myself, but it looks very easy to do this authoring. And all the tweakable data easily exposed for final in-game or in-engine tweaking, and all the debugging features available. And yeah, this was a fairly easy task to integrate into the game engine. It doesn't impose anything particular on you. It fits into normal rendering architectures, and so worked well there. So on to some live demos.
All right. So we're going to show a few assets that are using the CCP character system, which is the system that Incarna is using. But I should note that these are not specific Incarna assets that we're showing. So here's an example of a model that is fairly complex. The dress drags along the ground. The hair is simulated as well. And now, of course, this is not a cloth simulation demo. We're just animating the hair using cloth simulation. She's moving around pretty freely. She's twisting around. The dress follows her and stays on the ground. I can add some wind to it, wind with a little bit of turbulence, and it still works. All the collision volumes and stuff are doing what they're supposed to be doing. Of course, and this dress has a really high range of freedom here. If I wanted to play it safe, I would restrict the max distance on this to make sure that it didn't have any chance of getting tangled. Say, give it a foot or two of freedom, but no more than that. This of course leads to less fidelity in the simulation, but that's a trade-off you have to make. You either give it all the freedom you need and tune it in such a way that it can, or you simply restrict the freedom and save yourself some trouble. Then we have some more. Here's another dress. You saw her touching her hair there. We asked the animators to give us an animation that that could show off cloth simulation to some extent. They said, "Okay, we'll have her touch her hair," and we said, "Okay." Well, anyway, we were kind of surprised, but it actually works out pretty decently. And this is another dress that is probably definitely on the tricky side. As you can see, it is lying on top of itself on the ground. It is twisting around the girl as she moves. It's even longer than the black one, and yet it doesn't really mess itself up. Of course, having a skirt of that size is something to watch out for in general, because you can't easily put gun holsters under there and reach them. But that is something that you have to figure out with your game. Can you do this, or do you have other considerations when it comes to where you can simulate and where you can't? Now, so far the girls are just standing on flat ground planes. But what about when the ground plane isn't quite flat? What do you do then? Well, I'm glad you asked. Same girl, just walking across a flight of stairs. And yeah, as you can see, it's acting pretty naturally on top of slightly more complex terrain. Also, I should mention that these assets are actually built to spec. They haven't been tessellated in any crazy way to make them fit a demo. Of course, we built them knowing that one day they would be simulated, and so, for example, they are built with a very uniform, vertex spacing to allow them to collide properly, because the collision is, of course, on a per vertex basis, and so on. But essentially, I mean, these assets are for real. Now, of course, we might get in slight trouble once we start, doing pile drivers and stuff on dresses like this, but
Don't show up for a wrestling match in a dress like that.
All right, so we're giving it back to Munir, and he's going to give you an overview of what the rest of the Apex package does.
Thank you. So I'm just going to give an overview of what other modules we provide. One of them is, for example, Apex Destruction. And in case of Apex Destruction, it's possible to provide full and partial destructible environments. Over here you see an example where we have different materials, different destructible materials. We have wood, dry walls, and you see a lot of debris flying around based on that destruction. And it just provides a much more immersive environment, especially having that in games. And all the destructibles were actually authored with a tool called Physics Lab. I'm going to show that in a while. And you can see, depending on your compute platform, you can have basically the full amount of all the destructible debris on your ground, or if you're just using it on a low-powered compute platform, you're going to see less destructible elements over there. The tool itself is Physics Lab. It's a standalone tool, and it allows you to load in, for example, a wall, which you see in this particular example. And in here we're showing actually how to do chippable walls. Chippable walls are good for games where you don't want to change the AI path. You want to make sure that as soon as a player is destructing a wall, you're not opening a new pathways. And so what you want to do in this particular case, you just want to make sure that you can just destruct the outer face of that wall. In order to do that, we have here a brick wall. So you want to make sure that when you destruct the brick wall, that you're actually going to see the bricks themselves. And therefore, we have something called a fracture map. A fracture map is similar to a texture map. It allows the artist to define how the wall should be broken into pieces. In addition to that one, as soon as you destruct the bricks themselves, you want them to be destructed further on. And there you can define different levels of destruction hierarchies. And you can add noise levels as well, just to make sure that it really looks like bricks. Then afterwards, there's a preview mode. It's a kind of like a playground, and you can test it out within the tool itself. So it's basically what you see is what you get. And at the end, you can actually, we integrated that particular wall into a game, into UE3, the deck level. And you can see as soon as you shoot at it, you see how all the bricks fall down, how you have more destruction in there, and it just provides a more immersive environment. In addition to Apex Destruction, we have something called Apex Particles. In here, these particles basically collide against the physics environment, so you have full collision, and they interact with everything. Like, for example, here you can see the spider going through the smoke, and the smoke kind of got pushed away. You have full weapon destruction, destructible debris, and you see also how the smoke is getting pushed away based on the force fields. And you can use basically particles for almost everything. You have here particles based on sparks. And it's actually very difficult as soon as you're getting used to the amount of particles and play with that environment. If you go back, the game just looks pretty static. So it's a little bit tricky. Similar to Destruction, we again have a Physics Lab to author that one. Within the tool itself, you can specify the emission rates and can play around and change parameters and have a look at it in real time. Then we have one module called Apex Turbulence. Apex Turbulence, we used that in Dark Void, a game which was just released a couple of weeks ago. And in there we replaced some of the existing particle effects. Like over here you see as soon as the disintegrator gun is shot, you can see sprites getting pushed away. They collide a little bit with the environment, but not a lot. And we replaced that one with actual turbulence. In here you see it's a full real-time simulation, fluid real-time simulation. And every shot, every time it basically interacts with one character, you're seeing 20K particles. And you can actually shoot several characters as well. So it's pretty compute intensive, but it also provides much more realism. We did not only do that for the disintegrator, the weapon effect, we also did that for the jetpack. And the previous effect was basically just a graphical effect, which you can see over here. There's not really a lot going on. And we changed that one and we used actual Apex Turbulence, which provides then realistic looking smoke. And that's what you see over here. And you can tell already it looks much more cinematic. In total, we used actually in that game roughly 100K particles in order to do all those effects together. In addition to that one, we worked together with SpeedTree and we integrated Apex Vegetation into the SpeedTree modeler. That allows you now, you can basically provide full and partial tree destruction, and it's possible to provide actual physical simulation on the trees. And that one, you can see that actually over here. We have a quick video which shows you how it got integrated into SpeedTree itself. Well, video is not running. I'm going to show the video afterwards. But what happens over here is basically everything can, the tree itself, you can collide boxes against it, and everything is destructible. You have actual Apex emitters as well. 1 minute, let me just get that on video up.
I'll start something up in the meantime.
Oh, there it is. Okay. So over here we can see this was taken within the tool itself. You have full interaction. As soon as you shoot boxes into the tree, branches fall off, and you actually also can see apples, for example, falling down, as well as leaves. So finally it allows you to actually basically Apex Vegetation allows you to blow life into speed trees, and they're now fully interactive. And it's basically you can create trees as you did before using SpeedTree Modeler, and with a couple of clicks, they're immediately fully interactive. Okay, that pretty much concludes the presentation. So now we're basically open for questions.
But we should probably also mention that one pretty quick way of learning how to do cloud systems is to get hired by CCP. We're hiring. We have a booth in the Career Pavilion, so please stop by.
Okay. So, are there any questions?
I was wondering if the Apex stuff was actually available to other 3D apps other than Maya for integration.
Clothing is available the plugin is available for 3ds Max and Maya. Yeah.
So that's all the modules, or is there more? Is
Not for all the modules. Only
that's all standalone. The other modules.
Yeah,
that's
exactly.
Okay.
The other models are standalone, and only Apex Clothing is 3ds Max and Maya. Apex is actually free, so if you contact NVIDIA, we're going to provide it to you.
So, in essence, for the Maya tools alone and the potential for just playing around with it and making, drapery normal maps and stuff like that, if you're an artist that enjoys playing around with this stuff, it's pretty much a no-brainer. At least try it out.
Any other questions? So we actually also have a raffle. So just wait a minute. You can win a GTX 285. And again, if you're interested, just to make sure, NVIDIA is at the main expo, booth 1702, and CCP is in the Career Pavilion, booth 2502.
And this demo will be repeated on the show floor tomorrow at 1 in the NVIDIA Theater at the NVIDIA booth. So if you've got a programmer you want to bring along, do.
Yeah, thanks. So the winner is, I'm just going to read the number here, 195209. Okay, good. Thanks a lot.
Thank you.